Здравствуйте. Мы находимся на режимном объекте подстанция распределения электроэнергии на территории Республики Сербия. Перед вами вы видите установку по фильтрации, дегазации и обезвоживания трансформаторного масла. То состоит из вакуумного насоса, пульта управления, отвечающего за автоматизацию всего процесса по очистке масла.
I'm Professor Alexander Olovic from University of Belgrade, Faculty of Technology and Technology, and I was a member of the team developing process for PCB decontamination of contaminated a marking saying that masla, like in Russian, so it's dangerous, it contains PCBs. So for example, this transformer and the others around me, they contain PCBs up to the concentration of 1500 ppm. And our technology is basically designed to process contaminated oil, not pure PCBs. That is the difference. So basically we can't process pure PCBs. This is just to process oils within those transformers which contain contaminated oils. So in the whole process, due to the dispersed nature of this contamination, you can find PCB contaminated oils in numerous transformers. So this is just from one city. And the first step is of course, to remove this contaminated oil from the transformers. They should be removed from the network, and here they are. This is the place where we actually extract oils. So we empty the transformer, and then we see the flow of contaminated oil from the transformers to the process unit. This unit is over there, and the technology is based on reactive destruction of PCBs. So basically what we do is to remove PCB by chemical reaction, not to extract it, but to react it and to remove it completely, to destroy it. Our unit is over there, and it is very important, at least in Serbia, to have mobile units. What is the benefit of having mobile units? Well, when you have a mobile unit, then you don't have to confine your process to one particular location. So basically you will treat contamination where it is, and you don't have to remove contaminated material from one place to another. So this unit over there was designed for the needs of Serbia and for the quantities and capacities that we see normally in Serbia. That is what actually determines the size of it. It can be bigger, it can be smaller, but this was the optimum size for Serbia. Units of this type can process 1.5 ton in 12 hours. So that is 1.5 daily shift. Of course, bigger units can be made easily. And of course, we can also make stationary units. That's even easier. So this unit over there is supported by a truck. And then we bring it to a particular location like this one. Then truck loads it there. Truck leaves, and we can then assemble in a place where we can contamination. Maybe I can show you now the process in a bit more detail. So maybe we could go that way. So this is the unit itself. As I said before, it's 1.5 ton in 12 hours capacity. Looking from the technology point of view, it contains basically 3 sections. First section is over there. It is where we do reaction. First we have to prepare specific chemicals in order to make reaction possible. There is no pressure in the system, and the temperature is up to 130 degrees C. After contacting oil with chemicals that can remove PCB or destroy, we actually transport or remove the oil to different parts and different section of the unit where we remove those chemicals from the oil. That is necessary because we want to regenerate the oil, so the oil will be used again. It is not thrown away. After separating our reactants, so those that are responsible for removal of PCB, then we have to treat oil to make it good enough and to make it possible to be used again in transformers. So the next section is practically purification of oil. That is what we do over here, where we actually remove contaminants from the oil by the means of absorption. So we have selective absorbents, columns, and after circulation of the oil within the columns for several cycles, we have oil which is essentially purified from the reactants which we needed before. Of course, these reactants are very chemically reactive and aggressive, so they have to be removed from the oil in order to make oil good for another use. After removing those remaining chemicals, we will transport oil to this unit over here, where we actually do filtration and removal of water. So that is typical unit that can be seen all over power stations for conditioning of oils, where you actually remove mechanical particles or water which is present above the certain level which is safe for usage. After that section over there, the oil can be returned safely to transformers and used again. When we fill the transformers once more with this oil, I was showing you that red label saying that the equipment is PCB contaminated. When we remove this PCB contamination, we can put the white label saying that the equipment is PCB free. The level of PCB permitted in Serbia in transformers is set at 50 ppm. So when we are below that concentration, the PCB is the transformer, and the whole equipment is considered to be PCB free and legitimate to be used. Everyday operation. That is basically important for this unit. Of course, unit can be, as I was saying, can be engineered to be larger capacity, to be stationary, to be, let's say, fully automated also. So control systems can be designed to be almost up to full automated. And that is all. Thank you.